Right, for this tutorial we're looking at angles inside shapes and properties of some of the shapes, and then we'll go on to answering some questions. So just a little bit of revision, just we need to know that angles in a triangle add up to, and hopefully you know it's 180 degrees, and angles in a quadrilateral add up to 360 degrees. So if you've got a kite or a rhombus, a square, a rectangle, the corners, the angles will add up to 360 degrees. Okay. Some other things we need to know. If we have a regular shape like this one, a regular pentagon where all sides are the same length, then we can find this interior angle, the one from each side to the centre. I'm just going to draw this in now for you. So if this was split into 5 little triangles, all the same size, then we can work out the angle in each of these triangles. They're all going to be the same, this one, and you can see that they join up to make one full circle, so they're all going to add up to 360. So we can find each of them by doing 360 degrees divided by, we have 5, so that's going to be 72 degrees. So each one of these we can work in would be 72 degrees. So you can do that for any regular shape. Next here I've got a regular hexagon, so each angle here, again, all of these make a full circle. They're all the same size, so we can find the size of one of them by doing 360 degrees divided by 6, which would be 60 degrees. Last one I've got here is a regular octagon. That could be any regular shape at all, but regular octagon, we've got the 8 angles in the middle here. So if we want to find the size of one of them, we're going to do 360 degrees divided by 8, which is going to be 45 degrees. So each one here is 45 degrees. So that knowledge is a bit of revision, really, these ones. Some of the stuff that we've learned new at National 5 has been with some of the shapes inside circles. So first one we're going to start with is by drawing a diameter in, so from one side to another going through the centre. Now if we were to make a triangle that joined the sides joined at any point on the side of the circle, so I'm going to go up here. We're making a triangle with the diameter. Any point on that side of the circle, as long as this one's through the diameter, this angle is going to be 90 degrees. So I'll just do another example. It could be anywhere. You draw the diameter. The point could be anywhere. It could be down here. Go from that point to the two sides of the diameter. And we know that this angle here is 90 degrees. So that's one of the first things you need to know at National 5. Another one is if you draw a chord. So a chord is a line here that from one side of the circle to another just doesn't go through the centre. So it's not quite like the diameter. It doesn't go through the centre. If you were to then draw a triangle, joining the other two sides from the centre, we know we have an isosceles triangle because these two sides from the centre will be the radius, both the radius because they're both from the centre to a side, which gives us an isosceles triangle, which also means if we know the size of this angle, we know the size of this one. So if this was 28 degrees, this one would be 28 degrees. One other thing to note, and that is tangents. So tangent is a line which meets the circle just at one point. So if I was to draw one here, we see that that meets this circle, that line at just this one point there. So if we were to draw the radius from the centre here to that point, we then know that the angle the radius makes with that point and the tangent is 90 degrees. Tangent could be anywhere. I'll just draw one more over here. So we've got the tangent meeting the circle at one point. You then draw the radius to that point, and we know that that angle from the radius to the tangent is 90 degrees. That's pretty much all the knowledge you need to have at National 5 to then answer some of the questions that test you on this sort of thing. So we're now ready to look at some questions. First one I'm going to look at is National 5, past paper 1, question 3. So you can see that we now have quite a few of these things drawn together inside the circle. AC is a tangent to the circle, centre O with contact B. So let's mark in things as we go. AC, this line here, is a tangent to the circle, centre O with the point of contact B. So that must mean that this whole angle, I'm just going to draw it quite big because I'm trying to go around the other one that's been drawn in. That was a huge right angle, but that one there is a right angle. Also on the other side, there, down to the, all the way to the tangent, so make sure you don't stop at a line before, is a right angle. DE is a diameter, there we go, of the circle, and F is a point of contact on the circumference. So we've got this diameter, we've got a triangle being made by going to a point in the circle, so we also know that this one here is 90 degrees. So we've marked in two new things to help us. Angle ABD and DEF, the 77 degrees and the 64 has been marked in for us. Calculate the size of the angle BDF. So let's just work that out. So BDF, so it's this angle all the way along here. So you can see that actually it's already been split into these two little angles, so we might be able to find each one and add them together. So let's fill in what we've got, other things that we can find. We've got this 90 degree angle and we've got 77 degrees of it has been marked in already. Actually, we could work out what this one is here that I've marked in red. Because if the whole thing is 77 degrees, this one that I've marked in red must be the 90 degrees minus the 77 degrees. So this one here is going to be 13 degrees. Now, I don't know if you've noticed, but we've got a chord here joining at the centre, which makes this here your isosceles triangle. So if this one's 13 degrees, this one in here is also 13 degrees. So we're already a little bit closer. We've already found one section of the angle we're trying to find. We just need to find this one here so that we've got the whole angle. So looking at this triangle here, we can find this because we know the other two angles. This is 90 and this is 64 degrees. So we know that all three angles add up to 180 degrees. So you would do 180 degrees minus the 90 plus the 64. Which equals 26 degrees. So we've got this one here is 13 degrees, this one is 26 degrees. So we know that our angle BDF, the one that we were looking for, BDF, the one that we were looking for, will be 13 degrees plus 26 degrees, so 39 degrees. And actually use some of the knowledge that we've just been speaking about earlier in the video to find that angle that we were looking for. Right, let's look at another one. This one's different, slightly different because it's not just finding angles. So the top of the table in the shape of a rectangular hexagon, so we've got, the top of the table is in the shape of a rectangular hexagon. That should be regular hexagon. I think it's just been typed wrong. So top of the table is in the shape of a regular hexagon, a bit more useful. The three diagonals of the hexagon, which are shown as dotted as the dotted line, in the diagram below, each have length 40 centimetres. So it says the three diagonals, so 40 centimetres is 1, 2, 3 diagonals. Calculate the area of the top of the table. Okay, so we don't really know how to find the area of a regular hexagon. We do know how to find the area of a triangle. We have all these little triangles, so we could pull out one of them, any one, find the area of that triangle, and then multiply it by 6. Sorry, that wasn't a very good sketch. So we need two sides in an angle to be able to find the area of this triangle. So the angle, let's do this first. So we know that to find an angle inside a regular shape, we take 360 degrees, the whole one, and divide it by 1, 2, 3, 4, 5, 6. 360 degrees divided by 6, and we've got 60 degrees. So 60 degrees in here, so we've got our little triangle with 60 degrees. Now using the area of a triangle formula, which you are given at the start, we need the length of these two. So the three diagonals of the hexagon are at 40, so if the whole diagonal is 40, then each of these are 20 centimetres. So I'll just write 20 and 20. So to find the area of a triangle, you can look at your formula sheet. The formula is a half AB sine C. And if you're not sure of this formula, there's another video on using the area of a triangle formula. So you have to just make sure that the two sides that you have and the angle's in between those two sides. So a half times 20 times 20 times sine 60. So we've got, a half times 20 times 20 times sine 60. So 173.205 dot dot dot. So the area is 173.2 centimetres, yeah, squared centimetres. And so the area of the table, top of the table, is going to be at 173.2 multiplied by 6, because we have 6 triangles. 173.2 multiplied by 6. So we have 1039.2 squared centimetres. And that's you. Right, we're going to look maybe at one more here. And this is a little bit more like the first example we did. We've got a circle with some triangles in there, and we're going to try and find the size of the angle GLK. So what have we been told? The tangent MN touches the circle at centre, centre O at L. So we know that it's a tangent. From that radius down to the tangent is 90 degrees. From that radius down to the tangent, 90 degrees on either side. It's marked in angle GLN for us, which is 47 degrees, and angle KPL, which is 31 degrees. Find the size of the angle GLK. So GLK. So the one we're looking for is this one all the way here. Right, you might have noticed already a way to start to tackle this. If we can find this angle here, the one that I'm shading in red, then we've got some of the angle anyway. So 90 degrees is all the way down to the tangent. We know that that bit's 40 degrees, so the first bit we're going to do is 90 degrees minus 47, so 43 degrees for this bit here. Okay, we've got part of the angle that we were looking for. The other half, or the other section here, we're going to look at what else we have. This is the diameter. So we know that if we've got a diameter, we've got a triangle that meets at a point, this one here is 90 degrees. So our other section here, we can find by using the 90 degrees, the 31 degrees, and take it away from 180 to find that one there. So 180 minus the 90 and the 31 added together. So it's going to be 59 degrees. The whole thing is going to be, angle GLK, add those two together, 43 degrees plus 59 degrees is 102 degrees. And that's you. You're ready to try some of these questions yourself.